Okay, so we have the question. How much would the average cost be if 87.8% of the costs were less than $33,000? So we're trying to figure out how much would the average cost be. In other words, we're trying to figure out mu, where a standard deviation is still $9,000. I can't highlight that. Okay. So, write down what we know. Sigma equals 9,000. Our x variable will be the 33. Mu is unknown. Z is unknown given our Z table. So in order to solve this, we're going to have to figure out the area under the curve and then put it through our function to get, sorry, my heart is, oh Jesus Christ. X is less than 33,000 equals 0.878. Finding the complement of that, 1 minus 0.878 gives you 0.1 minus 0.878, 122. And so we know that given that this is 33,000, this shaded area is 0.122. And the rest is the 87.8. But our Z table only gives us things to the right of the mean. So, in order to get the Z table, we will going to have to take the 0.5 and then deduct the 0.122 to get 0.378. And then referring to our Z table, which is here, I've already highlighted it, great. 0.378 is between these two numbers. Take the average, 0. And you get 0.065 or something. .065, and so we will take that, and it corresponds with 1.1. So 1.16 is the standard deviation. But you actually don't need to know that value. What you need to know is that 3.78 equates to this area. And this is where it gets a bit tricky in statistics, is sometimes you are given numbers that you don't necessarily need to know. And so in order to compute the average cost, you're going to have to take your, so say you only have your Z equation, where it is x minus mu over sigma. Rearranging and solving for mu, you're going to get Z sigma, and this will be minus x. It equals negative mu, so and the interesting thing here is, because in the problem it said 87.7%, what would the average cost be if 87.8% of the costs were less than this value? We're talking about the whole function and not just this. So you're going to have to add this area with the larger area, which you can do, and you can get 0.3. I might do this on the line below. Times your sigma, which is 9,000, minus your x. And it's going to equal negative, just get rid of the negative. $25,098. That will be your average cost if 87.8% of the costs were less than $33,000. Hope that makes sense. And I'll show you a quick way to do it, where your givens are 9 grand, X is 33, and your Z is given to you in the question is 0.878. Given our Z table readings, it only shows that part. So you have to add the figure to the rest of the bell curve. But if you're given these, and you want the probability that X is less than 33,000 equals 0.878, you can rearrange everything to have P of X is less than, P of Z is less than X minus mu over sigma. equals 0.878, which is just going to be the probability. Well, you don't have to write the p at this point. Minus mu. And then rearranging, you're going to have and 98. So that's a quick way to do it if you plug in the formula and rearrange. But given our Z table, we had to find it in the Z table, average them, take the average, add that to 0.5 in order to fulfill the rest of the probability. Otherwise you'd be cutting yourself short, and you can find the average through that.